All right, kids, we're going to go over some of these problems here from our pre-test, okay, in order for you to hopefully get a better grade than you might have gotten before. So these are points of tangency, so we just have to set these two parts equal to each other. So we set x squared plus 2x equal to x squared plus 8x minus 24. Okay, so now in solving this, the x squareds can cancel out with each other. I'm going to bring the 2x onto the right side with a 6 because I'm going to subtract it. And then I'm going to add the 24 to the other side because you want to separate your variables and your numbers. And when I do that, I get x equals 4, okay, which is not the answer because it wants the length of AD. So I'm going to do 4 squared plus 2 times 4, 16 plus 8 is 24. Okay, so that should be the answer here for the length of AD. Okay, super duper. Let's see about number 2per. Got to erase all this, I guess. Okay, here we have a very nice tangent-secant problem. Well, not really. It's not a secant just yet. Right now, it's just a tangent problem. And a right triangle. So we can use Pythagoras, or we can use our swank way that we talked about yesterday of extending this. Hey, Mr. McKenna. So that we actually have a secant length times a tangent. So I'm going to change this into a secant tangent. So remember, that's the tangent squared, right? The tangent part squared equals the entire length. Okay, so the entire length of this secant is 2x plus 5, and the outside portion of the secant is 5. Okay, so now I'm going to solve this equation. 10 squared is 100. Okay, distributing over here gives me 10x plus 25. So 75 equals 10x. So x equals 7.5, and that is the length of your radius. Okay, very similar to that. Okay, so we extend that line into a diameter so that you have an entire secant before we move on. Okay, number 3, let's see. Let's get to erasing some of this also. Now this one looks like we want to find the length of an arc. So this is looking for an arc length. Okay, an arc length. So in order to find the arc length, we're going to use a proportion. Okay, an arc length is a portion of the circumference. So we put x as your arc length over 2 pi r. Oops, that should be 11. Let me erase that, not a 3, 11. The radius is 11. Equals 156 over 360. So this is our proportion that we use anytime we're trying to figure out what the arc length is. So 156 times 22 times pi divided by 360 is an arc length of 29.950. It is the length of the arc from A around to B if we have a radius of 11. Okay, so we're cross multiplying here, dividing it by 360, and that tells us what our arc length is going to be. Okay, here we are solving this one. This is a secant-secant problem. So we have to find the entire length of our secant and multiply it by the portion that's on the outside. Okay, so our entire length is 4 plus x. The outside portion is x, so 4 plus x times x equals the entire length of our other segment, 7 plus 5 is 12, times the outside portion, which is 5. Okay, so then now we have this nice algebraic equation, 4x plus x squared equals 60. So because I have an x term and a squared term and a number, I'm going to make and solve a quadratic. So I get everything on one side and set it equal to 0. Okay, so then this can factor. What numbers multiply to give us negative 60 and add to give 4? Well, those numbers, I believe, are 10 and negative 6. Okay, 10 times 6 is 60, 10 minus 6 is 4. So we have x plus 10 as a factor and x minus 6 as a factor. And since we're multiplying them together to get 0, either this number has to be 0 or that number has to be 0. So we get negative 10 as one of our answers or positive 6. Okay, hopefully you know we can't ever have a negative length in geometry. So positive 6 is our only solution to this problem. Let's see what else we have. Oh, we are converting from degrees to radians. Or in this case, from radians to degrees. So to convert from a radian to degree, you multiply by 180 and we divide by pi. Okay, and the pi's naturally cancel each other out, and we can write down our answer. So let's see, 5 pi over 4 times 180 divided by pi. Okay, so our pi's cancel out. So we're basically left with 5 times 180 divided by 4. So 5 times 180, that's 900. If I divide that by 4, that gives me 225 as the degree. Okay, so same thing with pi over 15. I multiply by 180 and I divide by pi. Okay, so basically your pi's cancel out, so I'm just doing 180 divided by 15. And 180 divided by 15 is 12 degrees. Okay, so pretty not bad when we're going from a radian to a degree. But let's see, what else do we have? Oh, we have another one of these things. Okay, so this is a segment called a chord-chord, right? Notice that there are two chords and they intersect each other. So they are proportional, and we will be doing a lot of multiplying here as we're trying to solve this. Okay, we're going to multiply each portion of our chords together. Okay, so I'm going to multiply the 4 times x because those belong to the same chord. And I'm also going to multiply the 2 times the 10 because those belong to the same chord. Okay, so this is how it works. You multiply down the same chord. And that means that this value of x has to be 5. Okay, and that's how we do a chord-chord type of a problem. Oh my goodness, this one is bigger. The length of the minor arc is 12 pi. So from B to C is 12 pi units long. That is the arc length. Okay, so this length of the arc, if you were to put a string around the outside, that's 12 pi inches long. And the measure of the arc is 46 degrees. Okay, so the arc measure and the central angle are the same. So we want to figure out what the radius is. So once again, we're going to use that proportion of arc length over circumference, which in this case is 2 pi r, since we don't know what the radius is, equals 46 over 180. You know, I can do a little bit of canceling and simplifying, right? This pi cancels with that pi, and I can divide my 12 by 2 and get 6. So I now have 6 times 180 equals 46r, okay, when I cross multiply. So 6 times 180 is not that. 1080. So when I divide 1080 by 46, I get a radius of 23.478 as my radius. Okay, so we're trying to solve this equation for r by doing a little bit of simplifying first. Let's see what else we have on here. Oh, a wonderful other angle problem. So this is a secant and a tangent. Okay, so once again, we multiply the entire length of the secant times the outside portion, and that needs to equal to your tangent side squared, because for a tangent, the entire length and the outside portion are the same. So the entire length times the outside equals the tangent squared. So 10 plus 2 is the entire length times the outside of 2 equals the tangent part squared. Okay, where this is, of course, your tangent. So 12 times 2 is 24. So x equals the square root of 24. And since it says round to 3 decimal places, I can put that into my calculator and get 4.899 when I round to 3 decimals. Let's see about number 9. Aha! So this one is one of your congruent tangents. Okay? Basically, you notice that chords, your two chords, AB and KC, are the same length. Okay? Because they're the same distance from your center. So the congruent chords theorem says that we would set 4x minus 6 equal to 2x plus 10. Okay, and we would, of course, solve this for x and get x equals 8. So KC, if we want to find out what KC is, we plug 8 back in here. 2 times 8 is 16. 16 plus 10 is 26. So the answer to this question is 26 because that's what the question is. What is the length of KC? All right, number 10 here, we're on to another secant-secant problem. So it's the entire secant length times the outside portion equals the entire other secant length times its outside portion. So this has an entire length of x plus 6. So x plus 6 times 6 equals 10 plus 5. 10 plus 5, well, that's 15. I don't have to actually add that together. I can just write 15 times 5, the outside length. Okay, so doing some distribution, 6x plus 36 equals 75. 75 minus 36 is 39. And when I divide 39 by 6, I get 6.5. So that is the length of this part of my chord, has to be 6.5 units long. Okie dokie, and the last one we have here is a couple of degrees that we're going to change into radians. Okay, so there's two ways that we can represent a radian. One way is by writing it in a fraction of pi, right? A fraction of pi. The other way is to actually put it in your calculator. So I'm going to do it both ways here. So in order to change my degree into a radian, I multiply by pi and divide by 180. Okay, now 72 and 180, I need to find a common multiplier. Okay, I know that 9 goes into both 72 and 180. So what if I divide them both by 9? That gives me 8 pi on top and 20 on the bottom. Okay, which has some more, right? 8 and 20, I can divide both of those by 4. So that gives me 2 pi on top and 5 on the bottom. Okay, now that would be in terms of pi, 2 pi over 5. But if I'm going to actually write it as a decimal, I'm going to put this into my calculator and get 1.26 as the radian measure. So 1.26 radians, or 2 pi over 5 radians. These are equivalents. And what about that other one, 330? We multiply it by pi and we divide it by 180. Okay, now I know both of these have a 30, right? Both of these are divisible by 30, 33, and I know 18 is. So if I divide them both by 30, That gives me 11 pi on top and 6 on the bottom. Okay, so that is the fraction with pi, 11 pi over 6. But let's put it in our calculator, 11 times pi divided by 6. And that gives me a 5.76 radians as the decimal. Okay, when we round it to 2 decimal places. So if you're having any trouble, go back and rewatch these videos, right? Rewind it and watch it again. And if not, then fantastic. Hopefully you'll have a fantastic time on your test tomorrow. Peace in.